start the class. Right, my first lesson is on the sequence and trying to figure out the missing numbers. Okay, maybe you already learned, haven't seen this kind of problem already before. Let's try to look at the first problem. Okay, so we are given a sequence of numbers. Okay, and that is missing. Okay, now we're trying to find the missing number. Okay. Now you look at this sequence number. There's a pattern there. Okay, and you want to see how? Yeah, you have to see first how this number changes, right? And from 1 to 4, from 4 to 7, from 7 to 10. Okay, and as you can see that those numbers are increasing, right? And they increase by what, right? You find out it's increasing by 3. So what you can do is, okay, you mark it here, plus 3, you get 4, plus 3, so you get 7, plus 3, you get 10, then plus 3. So the answer is, and 13, 10 plus 3, which is 13. Okay, great. Yeah, we have Albert here. Okay, Albert, give me the answer. Okay, Albert Einstein. All right, so now here's our second problem. We have a 4, 2 and 4. If we do not get the first one, you got ideas, right? And this time we have 2 missing numbers here in the sequence. And let's look at the pattern. Okay, let's look at the pattern. From 2 to 4, from 4 to 8, from 8 to 16, right? It's of course it's increasing, right? But this time it's a slightly different one. It's like the difference between 2 and 4 is 2, but then difference from between 2 and 8 is and 4. So it's not a constant increase. So actually, we get 4 is because we multiply by 2, okay? And then 4 multiplied by 2, you get 8. 8 multiplied by 2, you get 16. So that number will be, 32, right? So the answer is, the answer is 16 times 2. That is 32. Another one is 32 times 2. It's 64. Okay. Okay. So it's not always add a number to the previous one, right? It's possible you multiply the previous number, you get the next one, right? All right. All right. Now let's do some practice. Okay. You are given 3, 6, 9, 12, and then this number is missing, 18, 21. Okay. I wish everybody can give me the answers. Right, anyone else? Andy, are you working on the problem?
Oh, I'm just done with the problem.
Okay, yeah. No, I just said that you don't need to always post the answers, but if you have answers, sometimes post this. I know you're working on that. Okay. We have a Josh Zhu, Holden Zhu, Angelia Lu. Okay. Great. Thank you. So the patterns here, you can see that, this is you add 3 each time, right, to the previous number. And so that's why here it's add 3. So that's 12 plus 3, that's 15. Great. All right, next one, 2, 6, 18, and that number is missing, 162. Right. Yeah, there are two ways to post the answers. If you don't want people to see you get answers, so you're not sure, then you can post it to me directly, privately, or you can post it to everyone. Okay. Okay. So this is a this sequence increased very fast, right? And then you have 2, 6, 18. So more likely it's going to be the multiplication involved. Okay, multiplication involved. Okay, so you try this and find out it's multiplied by 3, and then multiply by 3, then 18 multiplied by 3, and that is going to be 54. Now, sometimes you double check, okay, because there's some strange sequence. Maybe there's another rule there. So you double check 54 times 3, and it's 162. Otherwise, probably it's not just multiplied by 3. Okay, so you double check, and then indeed the next one after 54 is 162. Okay. All right. So now let's try our next one. This is a brand new problem. I wanted to try first. Okay. I wanted to try first. Yeah, this type of problem we haven't done before. Now, if we get it, great. You tell me. Okay. Yeah, in reality, being a scientist, right? If you learn stuff from the book, you understand some material, then sometimes you see things brand new, okay? And you probably have to, figure it out by yourself. Okay? Wow. So Joshua has answers. Anyone else? Okay. All right. So let's look at this. This is from, yeah. Now you try an addition, right? Add the number, okay? You try the number, right? Add the 1 and 2, but then you find out that you have to add the 1, you get 2, but you got to add the 2 to 2, you get 4. But then you still have to find the pattern, right? It's add 1, 2, 3, then more likely you're going to add a 4, so you get another next number, right? If that number, let's put 11 here, but you double check, okay, for the rest of it. So then you add 5. Oh, you get 16. Then you add 6. Yeah, 16 plus 6, 22. Great. So this must be the answer. Okay. You see, so when you add a number, there's a pattern here. The number you're going to add it to the previous term, it's increasing. Okay, it's increasing. So that's why, and it's in 1, 2, 3, 4, 5, 6. So that's how do you get the answer. Okay, now you got an idea, right? So for the next problem, maybe you can do pretty fast. All right, 10, 11, 13, 16, 20, and numbers missing. Okay, but you also have to double check, the last one. Okay. right? Okay. Yeah. Hold it. Don't be too naughty. Okay, just post one answer. Don't type too many. Okay. Yeah, you have to stop here. So 10 to 11, increased by 1. 11 to 13 increased by 2. From 13 to 16, 3. Then here's plus 4, and this must plus 5. So 20 plus 5 is going to be 25. And then 25 plus 6 is 31. Great. So that matches. All right. Now, yeah, I'm glad you do the problem. Okay. So now, this is another brand new sequence. 23 and 4. Wow, going down. And 20, 6, 17, 8. This, we don't know. This, we don't know. 11 and 12. All right. All right. This is a pretty strange sequence. But you will see that, jump, going down, up, down, up, down, right? So probably, what do you think? Okay, so you see this sequence of numbers. I want you to think about first. Okay, it's different from previous sequences we have studied. Yeah, hold on, please hold. Okay, here's the point. I think this is we call it so-called alternating sequence. There are two sequences embedding here. Okay, and this is a sequence. Okay, so let's look at how those two sequences are mixed up. From 23 to 20, decreased by 3. From 20 to 17, decreased by 3, decreased by 3, decreased by 3. So that number is 17 minus 3, it's a 14. Okay, and then you double check. Minus 3, as 14 minus 3 is 11. Great. And from 2 to 6 to 8, every time plus 2. Okay, and plus 2. So I think the other number is 8 plus 2. So it's 10. You double check the 10 plus 2, you get 12. And that is answer. Okay, so that's why I say this sequence is totally different from the previous ones. All right. So there's so many different type of patterns there. You have to figure it out when you look at all the numbers. Your brain is a supercomputer. Okay, even computer can tell and can figure it out. Just like a secret code, when you try to tell somebody's number, you write down the sequence of numbers. There are some numbers missing, but if you can figure out a pattern and figure out that number, then you decode it, right? You figure it out. Missing the secret numbers. Okay, that's why there was in the United States there is a called the Secret Service Agency. Okay, and they hire lots of mathematicians that are working. Okay, National Security Agency. So National Security Agency, NSA. Okay, there's if you have a chance to visit that, and the majority of employees have a PhD in mathematics. It's hired by the government. Okay, they're dealing with those numbers. Okay, so 13, 2, 15, 4, 17, 8. Okay, so let's see. We have a sequence of this number, right? And then we have some numbers missing at the end. Now you get some ideas, right? This possibly This is it's an alternate, two sequences embedded into one plane. Two sequences mixed up, right? So you can try to figure it out. Angie Lee. Okay, Angie has answers. Joseph. Okay. So anyone else? Albert? Okay, anyone else? His answers? Okay, great. I'm glad to see that. All right, so that was the two sequences here. Okay. So from the one at the bottom here, 2, 4, 8, that means multiplied by 2. So it's multiplied by 2. And this one is increased by 3, increased by 2. Okay, increased by 2 and increased by 2. So the first number is 17 plus 2, it's 19. The second number will be 8 times 2, 16. Easy, right? All right. Okay. Hi, and let's do one more problem. We still have times. Yeah, 2, 9, 6, 10, 18, 11, 54, and try to figure out the last two numbers. Okay, so similarly, right? So it's alternating, yeah, this is we call it alternating series, okay? And then we also have this, and sorry, the last one I have to skip. Okay. So here we multiply by 3, multiply by 3, multiply by 3. The last one is 54 times 3, right? So 162. Then the other one is, right, is 11 plus 1, right? It's going to be 12. Good. Or is it 12 or 16? 162. Doesn't matter. All right. All right. So let's look at the next one. All right. The next one, I want to give you pretty enough time. Okay. 1. 1. Oh, still 1. 2. Okay. 3. Wow. Then 5. Then 8. Then 13. And then the last one is 34. Now, this is a brand new sequence. Okay, it's different from any of the previous one. So if we have to figure out a pattern, and as a rules we are using to generate the next one, then you have to be creative. Okay, you have to be creative. And but we have a couple answers from a student. Hi. I'm going to call somebody's name. I still working on that. Andy. We have many students with A beginning with Andy, Angela, and Angie.
Oh.
Okay. 3 of you have answers or not?
I'm still working on it.
Okay. I just said that the way to we generate the next number is totally different from the previous one. We have used the alternating series, right? Alternating sequence, there's the two sequences messed up with together. When you use a multiplication, we use addition. Right? Right? So from 1 to 1, nothing been changed. So I cannot say anything. From 1 to 2, from 2 to 3, it's increased by 1 every time. But then from 3 to 5, increased by 2. From 5 to 8, increased by 3. You see, here's the point, okay? So there are a couple ways to solve the problem. If you use addition, let's try addition. This is add 1. Then you add right? Then you add 2, okay? It looks like we're going to add 3, right? Add 3. Then add 4, right? Now add 5, actually, not 4. You see, that's the difference, right? And what's the logic here? Then you add what is next number, right? So you see that 1, 2, 3, 5. Okay, 1, 2, 3, 5 is this part. 1, 2, 3, 5. So right. So I guess we're going to add 8. Okay, if I add 8, then this number is 21. Now if I add the next one, I should add 13. So 21 plus 13, then that'll be 34. So this sequence just shift a little bit. It's actually the above sequence, right? 1, 2, 3, 4, 5, 6. That's one way to figure out. Another way you can figure it out is we add the previous 2 terms to get the next one. And the 1 plus 2, we get 3. 2 plus 3, we get 5. And 3 plus 5, we get the next one. The previous 2 terms, add them together, you generate the next one. And then 5 plus 8 is 13, right? 8 plus 13 is going to be 21 now, okay? And you double check, 13 plus 21 is going to be 34. So this is the answer, okay? Okay. All right, that's a good problem. We have a 2, 2, 4, 6, 10, 16. Now can you do this one? Yeah, so you can quickly see that this is going to be, just add them together, right? The previous 2 terms, so 10 plus 16 equals, right, 26. Yeah, 26 is the answer. Yeah. All right, so let's try next one. I'm not going to tell you. All right. Oh, yeah, can read. Yeah, I saw you disappeared and come back. Great. Okay, so this is a new problem. Okay, from it's increasing, so we want to figure out how it's increasing, right? We just try this first, add the 2, right? Most of the time, just you can solve this problem, right? Add the 4, and then this one we add 6, right? And that one we add the difference, we add 8. So I'm pretty sure I'm going to add a 10 to the next problem, right? So that will be should be 31. Okay. Yeah. You can also think about the difference of the two numbers. It's 2, 7 minus 3. It's given 4. The difference of two consecutive numbers gives you a new sequence. Then you can figure out the pattern. So then this number minus 21 should be equal to 10. Okay. Then that number is going to be, is going to be 31. Okay. That's another way to look at it. So we call it generating a new sequence by taking the subtraction. Okay. 3, 4, 6, 9, 13, a number. Okay. All right, let's try this. This is quite different. Right? We take a difference of those two numbers, right? 4 minus 3 equals 1. 6 minus 4, I get 2. 9 minus 6, I get 3. So 13 minus 9 is get 4. So clearly the next number minus 13 is going to be 5. So therefore that number is going to be, must be 18, right? So 18 is the answer. Great. All right, so now then the next one, still similar patterns, but we'll get a special new sequence. Okay, so 1, 4, yeah, sorry, not similar. It's a sequence, but it's a special sequence. Okay, if you're familiar with certain type of numbers, you probably can figure it out quickly. Yeah, look at all those numbers. Yeah, look at all those numbers. How do they look like, right? They are perfect squares. A perfect square means it's 1 square, 2 square, 3 square, 4 square, 5 square. Then next one should be 6 square. That should be 36. Okay, have you learned about perfect squares? Perfect square is a square of some integers. And this is just a sequence of perfect squares from the 1 square, 2 square, 3 square, 4 square, 5 square. Okay. All right, so you're familiar with this. Now let's do this next problem. 1, 2, 6, 15, 31, 56, and the next number. Okay. I wanted to try first. Okay, have you figured out? All right, let's see how it's increasing, right? We figured out, 2 minus 1 is 1, right? And the 6 minus 2 is 4. 15 minus 6 is going to be 9. So 31 minus 15 is going to be, 16, right? Then 56 minus 31, right? It's 25. Then what is number my, right? What is next number? This is a sequence of perfect squares. So the next one will be 36. So some number, right? And that number is going to be 56 plus 36. That's why it's 92. Okay, 92. 92 should be the right number. 92. Okay, so you add a sequence of you add a perfect squares to the previous term, but that sequence perfect square, it's increasing. Okay. All right, now let's take a look at the next one. I have wow, this is a pretty challenge. Okay, I'm not I decided I did skip it out. Let me look at the next one. Okay, so we are now a brand new sequence of numbers. We came up with the pairs instead of so the missing number. We're trying to figure out the missing number. Okay, in the last pair. Okay. So you take a look at the pairs of numbers. You see that this is 96. Okay, 96. Yeah. So you see that the difference of the two numbers in each pair is not constant. Okay, first of all. Okay. So the difference 100 minus 96, here's a 4. Okay. And then 97 minus 88, that is going to be 9, right? Okay, let's try. Okay, then 91 minus 75, that is going to be 16. So I look at those numbers, more likely the next number will be, those are perfect squares, 4, 9, 16, right? So more likely 79 minus that number is going to be 25, right? All right, so that number should be equal to 79 minus 25, right? It's going to be 54. 54, 79 minus 54 is 25. Okay, so this is this should be the answer, I guess. Okay, our next problem is I have 6, 9, 7, 8, 10, and 5, and this is a missing number. Okay. All right, now you can try to figure out the pattern. Okay, you not only just needed to look at the relationship between two numbers in each pair, you also have to look at the relationship among those pairs. Okay, then you can figure out the missing number. Okay, if you have answers, and please post it, tell me. Okay, so far only just for give me the answer. Okay, anyone else? Albert?
I don't know.
Angie?
Go
Hi.
for
So you're the, your brain is different from computer, right? It's not the, for computers, they scan all the numbers, all the pairs of numbers, and have to quickly figure out the pattern. Okay. But you will see that 9, yeah, if I show you the first one, then you probably figure out 6 plus 9 is 15, right? 7 plus 8 is also 15. 10 plus 5 15. So that number plus 13 is 15. Okay, they're all 15, so that number should be 2. Okay, got it. Yes. Okay. So how do I see that? Because 9, 6, 9, then I increase 6 to 7, then I decrease 9 to 8. So that means the sum is not changed. And then you double check 10 plus 15, right? 10 plus 5, that's 15. So I think this is, sometimes it's harder to explain, how do I see this pattern? Okay, more exercise you do and the more experience you're gonna get. Okay, 24, 2 and 12, 3 and 8, 4 and that number. Okay, and of course you can try some of it. Okay, add the two numbers together. But if I add the two numbers together, each pair gives you different sums. Maybe that's a logic. Maybe there's a pattern here, but probably it's not working. Right? Probably it's not working. All right. Yeah. And I find out multiplication that works because 1 times 24 equals 2 times 12 equals 3 times 8. That is 24. So 4 times that number should be 24, and that number must be 6. Okay? Yeah. All right. All right, let's try a different number. All right, so let's look at this sequence. Let's look at this sequence of pairs. Okay, and I'm trying to figure out the missing number. All right, so now clearly I cannot do the addition or multiplication. I don't see quickly I can find exclude those two ways to get to the next pair. And let's take the difference. Well, the difference does not give you the same number, right? That's okay. Let's try the difference, addition, multiplication. And then I get 4. 10 minus 1, I get 9. Okay, so 1, 4, 9, those are perfect squares. So that's why this number is going to be, is the next one, right? Is going to be 16. So that number should be 5 plus 16 plus 21. Okay. So you just try several different ways to this pair of numbers. Okay. And you generate a new sequence. So the new sequence has a pattern. Okay, the new sequence has a pattern. So for example, the next one, okay? The next one. You can use a multiplication, division, addition, and subtraction, right? Try all of them to see which one gives you a nice pattern. Wow, I have so many students give me an answer right now. Okay, so that's easy, right? So it's 2 plus 7 is 9, 4 plus 5 is 9, 1 plus 8 is 9, 3 plus that number should be equal to 9, and that number should be equal to 6. Okay, great. And then 12, 9, 8, 15, 12, 18, 15, this missing number, 13. Okay? Okay, so the difference of the two numbers in each pair is always 3. Okay, this is a 3. So 15 minus 12 is 3. 18 minus 15 is 3. So that number must be 16, not a 26. Yeah, 16. Be careful. All right. So here 14 and 2. 28 and 4. 42 and 6. And what is that number? Missing number. Okay, now this time we have never used a division, right? So 14 over 2 is going to be 28 over 4. It's 42 over 6. Okay, then that number over 8, right? That's supposed to be, right? It's supposed to be 7, right? So that number should be 7 times 8, 56. Okay, 56 divided by 8 is going to be 7 always. Okay. All right, the next one. 610, 415, 12, 5, and that number and the 1. All right, well, we have some still not good answers. So actually, the 6 times 10 is 4 times 15, is 12 times 4, times 5. So they're all equal 60. So that number must be 60, okay? Because 60 times 1 is 60. All right, now the next one would be slightly different, okay? So 13, 12. and there's more connection between two pairs, okay? And usually, the previous problems, the relationship between the pairs is just something same number, right? But now we are going to have a more complicated relationship between the pairs. Okay, so 13, 15, 13, 12, 15, 13, 14, 17, 14. Right? Right. Yeah, we see that is so this is a difference. Let's try this first. It's 1, and here I got 2, and here I got 3. So more likely, this is going to be 4, right? The difference. So that number should be equal to 19. Okay. So you generate, get a new sequence, and there's a pattern here. Right? There's a pattern here. Okay. Okay, here 7, 21, 11, 33, and 13, 39, and then 21 of that number. Okay, I was a missing number. Okay, so you see that the second number is the first number, 3 times the first number. Okay, so 7 times 3 is going to be 21. 11 times 3 is going to be 33. Right, 13 times 3 is 39. So 21 times 3 is the missing number, which is 63. Great. All right. And I have a 1 and a 4, 2 and 7, 3 and 10, and that missing number 13. All right, please work out this. Yeah, there are a couple ways to do. For example, I will try this one, 1, 2, 3, and I think it's 4 possibly. And 4, 7, 10, every time I add a 3. Okay, this is another way to think about. Maybe you did not think this way. Okay, so the answer is 3 plus 1, which is 4. Another way to do is you take the difference of the two numbers, which is 3 here, 7 minus 2, that's a 5. And then you see the pattern, right? That's probably you did it, right? It's a 7. And so 13 minus that number, I think is the next number, right? It's going to be 9. Okay, so that number is going to be 4, because 13 minus 4 equals 9. Okay, so there are some ways to do this. It's a different way. Okay, 26. Okay, I have 1, 4, 11, 34, 7, 22, and that is a missing number. Yeah. Okay. Well, now this is a challenge. Okay, not easy to figure it out. But we can try. Okay. Well, Albert has answers already. Great. So we see, right? We take a couple ways to do. Let's try this difference. 4 minus 1 is 3, right? And 34 minus 11, right? What is the number? Okay. 34 minus 11, and then try it. Maybe it works, maybe it does not work, right? And right, so 34 minus 11, and it's 23. Still looks pretty strange, right? 22 minus 7, right? And then 22 minus 7, there's, some, it's not that way, right? You cannot see the pattern, right? And no way you can do this. Okay. So the next try is, what we got here actually is the difference between, the difference between, 34, right? 11, 4, and let's focus on 11, 34, and 7, 21. I find out 34, okay, 34 is 11 times 3, and then add 1. And the 22 is 11 times, 7 times 3, plus 1. Okay, 7 times 3, and plus 1. Okay. And then you double check 4, right? 4 is, 4 is going to be 1 times 3 plus 1. So more likely that number 16, right? Is this number times 3 plus 1. Okay, so that number should be equal to 5. The 5 times. Okay, that's how I figured out. Okay, it's the last number, last problem. 1, 3, 11, 33, and 7, 21, and that number 4, and that'll be much easier because in here just the differences, right? And this is a 15, right? Yeah. So the second number is just the first number times certain number. Okay. So 3, 3, right? And the third times 3, right? So 11 times 3, right? And 1 times 3 is 3. 11 times 3 is 33. 7 times 3, that will be easier than the previous problem. And this number times 3 is 15. So that number must be equal to 5. Right? Must be equal to 5. All right. So I'm going to stop here today.